Hello, dear students. So this is our next lecture on these differential equations. So as you are already aware about this Legendre differential equation, and I already put you one assignment on to calculate this solution for this Legendre polynomial or Legendre differential equation using Frobenius method. And now today's topic is about, if you talk about this Legendre, this polynomial, so we can have every differential equation, especially which are present in our course, they have the corresponding those generative functions. So from generative functions, you can construct some sort of relation between the different coefficients of, suppose for this Legendre polynomial, right? And those are basically called a recurrence relation, right? So these are basic that Legendre polynomial, that's 1 minus x square p double dash of x minus that 2x p dash of x plus lambda p of x equal to 0. So this lambda can be, it can be some integer, it can be, but in so what we have discussed is that lambda is some n into n plus 1, so it's simply an integer, it takes those values. Now, as if I go back, let us revise some of the topics, some of the things related to this Legendre polynomial. So first is that this Legendre polynomial has regular singularity. So it has regular singularity at x equal to plus minus 1, because if you put at x equal to plus minus 1, right? So at x equal to plus minus 1, its solution will vanish, right? Because at x equal to plus 1 or minus 1, so that means it has solution. It has solution between minus 1 to plus 1. So that means the solution lies between plus 1 and minus 1. But it has solution at x equal to 0 also, right? So that means this, it has, we can say that, so it has this, these are basically regular singular points, or these are called a regular singularity. Okay. So that means it is series, it is solution will converge. So why the solution of this kind of differential equation will converge? So it will converge at x less than x less than plus 1 and x. So it will be between minus 1 and plus 1. Right? So you can say that. Right? But so let us talk about now the what is the corresponding generating functions for such kind of differential equation, right? As we have already talked about that Bessel differential equation, and you are already aware about so to how to get the different kinds of these relation between the different Bessel functions, which are called a recurrence relation. And similarly, we have the corresponding generating function for this differential equation also. So the generating function for this. So what is the generating function for this Legendre polynomial? So we define the generating function by g of x. So that's equal to. So this is the generating function, right? As I already told you. So what is generating function? It is basically the, we can say that the encoded form of that series of, like if we have this Legendre polynomial, so it is the encoded form of that, right? Okay. Or this will be equal further, that's equal to. Okay, so this Pn of x is our Legendre polynomial. Okay. And this is the corresponding generating function for this differential equation. Now, now first, or you can rewrite this as, okay, let me write one more step. So this is n starts from 0 to infinity. Right, so I can rewrite, because it is in the denominator, you can write this as 1 minus 2s x3 plus t square raised power minus, because इसको अगर हम न्यूमरेटर में लेंगे, so because it is plus 1 by 2, so it will be minus 1 by 2. Now first, let us, so what's our aim here? So first, let's have a quick look. So what's our aim? So our aim is to get that relation between the different coefficients of these this Legendre polynomial. right? So Pn of x, right? So that I can get by two ways. So first you take this generating function and you differentiate it with respect to, because we have this t and x, so differentiate this equation with respect to x and then differentiate it with respect to t. So that means, so by differentiating it, this generating function with respect to x or with respect to t, so we get two recurrence relation, the relation between the different coefficients of that Legendre polynomial. So firstly, let us differentiate this equation. Suppose this equation A. Now differentiate. Okay. So you know that. So this is our Legendre polynomial. So let us write this as, so that is our summation that n starts from 0 to infinity. So that's this. That's 1 minus 2 xt plus t square is power minus 1 by 2. Now if you differentiate this with respect to t here, so what should I get here? So this will be equal to, t raised for n minus 1. Okay, because you are differentiating this with respect to t, and the right hand side will be, okay, because so minus 2x xt will be minus 2x and t square will be 2xt. Okay. Now let's have a look on the right hand side, because you can take the 2 out from this bracket term, and so from here you can take that 2 out, so that 2 will cancel with this. Now minus you multiply to this. Okay. So that means I can write this as, okay, because so it's clear, because you need to multiply, तो minus से हमें multiply करना है इस term को, so it will be x minus t here, right? And that 2 you take out from here, from this term, and इस term में लगे दो पहले से ना, तो है कि connect करें formula तो इस sense, तो you can go to presentation. हुई कैसे convert नहीं कर सकते, ऐसे दोनों में option. Okay. So so you write here, so this will be x minus t here. Okay. So this will be equal to, okay, so you can write this as, that will be equal to, okay. Now take, because you can, instead of this, because this is equal to Pn of x Tn. So instead of this you write this summation n starts from 0 to infinity Pn of x t raised per n. Huh? So in the numerator you write this term, and this will be x minus t, and this you will take on the right hand side. So that means I can write this as, have a look. So whether it's correct or not. So first यहाँ पे मैंने क्या किया? So this NPN. So this is left hand side is as it is, but the right hand side, because you take this as summation n starts from 0 to infinity, Pn of x t raised for n and x minus t and this term. Because you can write this as minus 1 by 2, right? So it's clear. Now you multiply it on the right hand side. So this will be equal to, okay, because when you multiply this x to this term, so this will be x Pn of x t raised for n, now t. So this will be Pn of x t raised for n plus 1. Okay. Okay. Now right hand side, let's have a look on the right hand side. So I can rewrite this as, so this will be summation. Okay. So this is our left hand side, because you have 1 into this, so you have this 1 into this, so this is Pn of x t raised power n minus 1. Now 2x and n, then t raised power, it is n minus 1, and this is t raised power 1, right? Because this is t here. Okay. So this will be t raised power n here. Now t square multiplied to this term, so it will be n Pn of x t raised power n plus 1. So this was our left hand side. Let's have a look on the right hand side. So जो हमारा right hand side होगा, so that will be equal to summation n starts from 0 to infinity x Pn of x t raised power n plus n plus 1. Okay, because so our right hand side, that was as it is, because when you multiply x to this, so this x and then t, that's t raised power n plus 1. Now let's do one thing. Let's write the so we can do one thing. We can equate the coefficients of t raised power n on both sides, or you can equate the coefficients of x t raised power n also, right? Because we have t raised power n plus 1 here, t raised power n plus 1 here, and but here it is t raised power n minus 1. तो इसको मुझे क्या करना है? I need to shift that, or you can write that. So you can do one thing. You can equate the coefficients of t raised power n also. So it's up to us. तो यहाँ पे t raised power n है, तो इसको मुझे क्या करना है? I need to shift for this term, जो मेरी पहली टर्म है, इसको मुझे shift करना है n into n plus 1. Because when I shift that n to n plus 1, ये बन जाएगा t raised power n. तो यहाँ पे t raised power n already है. Now for this term, तो मुझे shift करना है n को n minus 1 से, because I will get here p n minus 1 t raised power n. And similarly, so this as it is, but for this you need to shift n to n minus 1, because you need to equate the same these powers of that t. So I'm equating the powers of that t raised power n, or you can equate the coefficients of t raised power n plus 1. So it's up to you. So accordingly you need to shift the value of n, right? So that means इस term के लिए मुझे क्या करना है? So I need to shift that n to n plus 1, right? So इस term के लिए, so this term will be as it is, but for this term you need to shift that n to n minus 1, right? And similarly for this term you need to shift that n to n minus. Okay, it's okay. Okay, so when I shift that, So what should I write here? So I can write here. So that is summation that n starts from minus 1 to infinity because n to n plus 1. So that's n plus 1 v of this first term. So let's have a look. That is xn because it is as it is. Now next term is, so ये shift करना है n to n plus 1, right? So plus that summation n starts from minus 1 to infinity, okay, and then n minus 1. So this my लेफ्ट हैंड साइड, तो राइट हैंड साइड क्या बन जाएगा, पहली टर्म एज इट इज आ जाएगी, बट सेकंड टर्म विल बी बिकॉज वी नीड टू शिफ्ट दैट n to n minus 1 बिकॉज पावर क्या आना चाहिए t रेज पर n, तो ये कब आएगा जब आप शिफ्ट करोगे n to n minus 1, right? But first term will be as it is on the right hand side, so that will be equal to x summation that n starts from 0 to infinity plus that. So that's minus here, sorry. So let's check whether it is correct, because I did a mistake here because this was minus here. So I should get here. So this should be minus. This should be minus. This should be minus. Why? Because you are writing x minus t. So x then second term will be minus, because minus t to this. So this will be minus. And now next term will be equal to. So similarly, you can write here for this one. So next term will be equal to, that is equal to minus that summation n starts from 1 to infinity p of n minus 1 of x. Right? Now you can do one thing. You can equate the coefficients of that t raised per n. Right? So you write down equate coefficients of t raised per n. Right? So we need to equate the coefficients of t raised per n on both sides. So this will be equal to n plus 1 right? Because okay, and the right hand side will be equal to, that is x. Okay. Or you can write this as, now you can take this 2xn on the right hand side and you combine this and this term. So ये क्या बन जाएगा, when you combine this and this term, so this will be that 2n plus 1 of x n of x, right? So that will be equal to, तो ये टर्म हम ये इस साइड लेंगे तो पहली टर्म क्या आएगी, that will be this thing. अब ये टर्म रहेगी, that is n plus 1 p of n plus 1 of x, right? Okay. तो क्योंकि मैंने 2x and pn of x राइट हैंड साइड लिया, तो एंड आई रोट फर्स्ट राइट हैंड साइड ऑफ दिस इक्वेशन, तो राइट हैंड साइड हमारा है बिकॉज दिस प्लस दिस टर्म यू आर कंबाइनिंग दिस टर्म एंड दिस टर्म, तो ये जो क्या आएगा 2n कॉमन आए, तो n plus 1 and x common आएगा x p n of x, so that is this. And now ये left hand side में मुझे लेना है, that's n plus 1 p of n plus 1, and you take this on the left hand side, so it is pn of x 1, and this will be plus here, so it will be npn of x, right? So this will be plus np of n minus 1, right? So this is our first recurrence solution, right? Because take the different values of that n. So this is basically the relation between, because if you put that n here, n equal to 0, so you will get that p0 of x will be equal to that p1 of x and p minus 1 of x. So that means this is simply the relation between the different quotients of those Legendre problem. Because so next time, tomorrow, I will talk about some more these recurrence relation related to this Legendre polynomial, and we'll talk about this orthogonality as well as the normalization condition. Because as I already told you, we can construct a set of this orthogonal these functions for this, for such kind of differential equation, because it basically satisfies our that Sturm Liouville's condition or Sturm Liouville's problem, right? So hopefully we'll discuss that in our next lecture. Thank you very much.